So in this topic we are going to learn what is the beats. So what is the beats here? So there we can see the graphical representation of that beats. So then what will happen, that's the vibration, the amplitudes of the vibrations are going to be moving in this direction. So there we can see. So if you take the normal vibrations of a single vibrations of that system, so then what happened, that's going to be moving in this direction, right? But in this case what will happen, the two vibrations of motions we have taken. So that's going to be x1 and x2 we have. So then what will happen in this case, one vibrations are moving in this direction, other directions are moving in this direction. And they are moving in the same direction at the same time. So then what happened, this is going to be a point of meeting is going to be taking place. So then these two are going, and after certain interval of time there is another point of is going to be taking. Such an interference is going to be coming to that system. So then what is the beats and how we are going to be evaluating here? The x-axis is going to be the time periods and y-axis is representing the amplitudes of the vibrations, and we know the time period, that's going to be 2 pi by omega. But in this case what will happen, two different frequencies is existed, that's going to be, we are writing 2 pi by omega n minus 2, and this the height is going to be considering as the 2 times of the amplitudes of the vibrations. So then what is the definition exactly for that? In this case, when two harmonic motions, right, we do have two harmonic motions passes to the same point, passes to the same point in a medium simultaneously, right? The resultant displacement in this case, the resultant displacement at this point is the vector sum of the displacements due to two component motions, right? And if you want to find out, we know that x1 and x2, that's going to be two displacements we do have. So but we have to find out the displacement at this point, that's going to be x is equal to x1 plus x2. These two vectors we are going to be taking. So already we do have seen in this topic of the superposition of the two harmonic motions. Then what will happen, x1 and x2 are going to be the harmonic motion, and the resultant motion also is representing or getting the harmonic motion itself. So then what we say, the resultant displacement at that point is the vector sum of the displacements due to the two components motion x1 and x2. So then this superposition of motion is called interference, right? So that's going to be at interference we are getting the bits of that system. So there we have seen the interference. As we know that at interference we are getting the bits. That's how it is going to be. Through definition we are going to be defining the phenomena of beats occurs as a result of interference between the two waves of the slightly different frequencies moving along the same straight line in the same direction. I'm going to be repeating that one. The phenomena, that means the phenomena of the beats occur, that's going to be occurs the results of the interference between. So there is an interference is coming between the x1 wave and the x2. These are the displacements of the system. So, and waves slightly different frequencies do have the different frequencies, that's going to be omega 1 and omega 2. Two different frequencies existing and moving along the same straight line in the same direction. This way, this phenomena of the beats occurring, that means the resultant of the resultant here, what is the resultant? The interference of the two waves we are going to be getting. So then we have seen the beats occurred at the interference of the two vibrating system to the frequency of the vibrating system, and that's going to be the resultant, the displacement, the resultant will occur the summation of these two vectors, the motions. So in this case, suppose when they are going to have two different frequencies. Okay, so in this case, I am going to be considering, first suppose, consider that a particular time, the two wave motions are in the same phase, right? They have the same different frequencies, but they are existed in the same phase. That phase we are going to be representing with the pi. So in this case, what will happen? x1 is equal to a1 sin omega t, right? Omega n1t, x2 is equal to a2 sin omega n2t plus pi. The pi is going to be, we don't have, but they are in the same phase. At this stage, the resultant amplitude of the vibrations will be maximum, because it has the same phase is there and the two different frequencies it has, then what will happen? It will generate the maximum amplitudes or maximum amplitudes of the vibrations. In other case, when the two motions are not in phase, they do have a different phases. Omega nt, second one we have omega n 2t plus pi. That means the phase is there. They are not in the same phase. So with each other, they produce the minimum amplitude of the vibrations. When they are in the same phase, we are getting the maximum. When they are not in the same phase, we are getting the minimum amplitudes of the vibrations. So then what happened? Again, after some time, the two motions are in phase and produce the maximum amplitude and then minimum amplitudes. This process will continue repeatedly. As you know, because of the phase differences, one time we are getting the maximum, one time we are getting the minimum of the amplitudes of the vibrations. So that this process goes on repeating and the resultant amplitude continuously keeps on changing from maximum to a minimum. Because sometimes the phases are going to be matching, then we will get the maximum. When the phases are different, then we are getting the minimum. This kind of the process will continue, keeps on changing the amplitudes of the vibration from maximum to the minimum. This phenomena is known as a beat. So this phenomena is going to be called as a beat, because the beat is occurring at the interference of the two harmonic motions of the vibrations by having the different frequencies.